Okay, we want to determine if the given vectors are orthogonal. Orthogonal means perpendicular. So we want to see if the given vectors in number 33 are perpendicular. Okay, so how do we do that? If the dot product of the two vectors come out to 0, then they are perpendicular. And we're going to show more why do we say that? If the dot product is equal to 0, so we're going to find out. Let's see, what's this? Okay, so we want to find the dot product. So I'm going to call the first vector u, and I'll call this one vector v. We are told to determine if they are perpendicular, orthogonal. Remember, the dot product of two vectors will be a scalar, just a number. It's not going to be a vector. Okay, so the x component of u multiply y component of v. So I have 1 multiply negative 20 is negative 20 plus the y component of u multiply y component of v. So I have 5 multiply negative 20, negative 4. And I have negative 20 again. Negative 20 plus negative 20 is negative 40. So the dot product is not 0. The vectors are not orthogonal. By the way, why do we say that if two vectors are why do we say that? If two vectors have a dot product of 0, they're orthogonal. What does it mean that two vectors, let's see, remember that the angle between two vectors cosine theta is equal to the dot product of two vectors, say u and v, over the magnitude of u multiplied magnitude of v. So if this comes out to be 0, it means that we are looking for the cosine inverse of 0. But we have seen in a unit circle that, okay, let's see, let's make a sketch. That will help a lot. So in our unit circle, this point right here, all the quadrantal angles on the right here, at top here, I have 0, 1. Any point on a unit circle is represented by xy, where x is the horizontal component and y is the vertical component. So x here is 0 and y is 1. Also, any point on, let me draw it here so that we can see better. All right, so this is 0, 1. So we just want to remember this. Now, any point on a unit circle is cos theta sine theta. We already know that from unit 1, so this is unit 4 already. And that means that cosine of 90 degrees, this is 90 degrees, cosine is quadrantal angle here. So cosine of 90 degrees is 0. We already know that. Since cosine of 90 degrees is 0, it means that if we're looking for cosine of 90 degrees, we can actually prove it using our calculator. So let me find let's find cosine inverse of 0. See what happens. So we want to make sure we know the meaning of if the dot product is 0, the vectors are orthogonal. So I'm going to find a cosine inverse. Before I do that, I'm going to go to mode and make sure that my mode is in degree. Oh yeah, it's in degrees. So second quit. Okay, so now I want to find the cosine inverse of 0. My answer is going to be in degree. And my calculator tells me it is 90 degrees. And so if the dot product is 0, then the angle between the vectors is going to be 90 degrees. So whenever I'm told to prove that two vectors are orthogonal, it means prove that the vectors are perpendicular. prove that the vectors are perpendicular. So let's go to the next one. We have already found number 33, the vectors are not orthogonal because the dot product is not 0. The dot product is not 0 in number 33, therefore it is not orthogonal. Those two vectors are not perpendicular. So let's go to number 34. It's already going to be in the exam, so you might want to know it. Find the, determine if the dot product of these two vectors is 0. Or another way of saying, is the angle between them 90 degrees? Two ways of knowing it. So let me find, I'm going to call this one vector u, call this one vector v. And then find u dot v. U dot v will be, I'm going to multiply the horizontal component of vector u with the horizontal component of vector v, vertical component with vertical component, and then I will have -1 plus 1. And -1 plus 1 is 0. Okay. So the dot product of the two vectors is equal to 0. Therefore, the vectors are orthogonal. Also, if I find the cosine theta is going to be u dot v over magnitude of u multiplied magnitude of v. It doesn't really matter what the denominator is because they're not going to be 0. It will not be 0 over 0. Numerator is already 0 over whatever quantity is right here. The important thing is that if I find a cosine inverse of 0, I'll get 90 degrees. Therefore, the two vectors are perpendicular, orthogonal. The two vectors are perpendicular, so they are orthogonal. That's what it means. And you will have this question. It's not as it sounds difficult, but it's not even difficult. Okay, so that is about perpendicular vectors or orthogonal vectors.